Oh, hello there. Didn't see you. My name is Dr. Carson, and today we're going to learn about some circuits. So let's start with the two main components. We'll first start with the wire, and we also have the battery. Now on schematics, the wire is literally just a line. It's super boring, but the battery gets more interesting. So a battery is just basically a bucket of electrons. So if you have what's called an incomplete circuit, which is when only one part of the wire is connected to the battery, it does nothing. The voltage just sticks in the bucket. But if you complete the circuit and put it and connect the wire both to the positive and negative side, current comes into play, which is measured by amps, and it just will push the voltage from the positive to the negative side. So one problem with circuits in general is if you allow too much voltage to go through the whole circuit, it'll actually catch on fire and explode. So one way to prevent this is to add a resistor, which is something that you would put onto the circuit, and there's plenty of objects that act as resistors, and what it does, it just takes a little bit of voltage out of the circulation so nothing catches on fire. So here's a sample problem that I've already worked out for you guys, and we are given a whole bunch of resistors and voltage, and we are asked to find current. So let's use this formula, which equals voltage equals current times total resistance. We are already given voltage, which is here saying it's 9. We don't know the total resistance, but we are given all of the resistors. So we have to find Req, which is the same as the total resistance, by just adding them all together. So Req equals all of them added together, which would equal 18. So now we are given R, and then we need to find I. So what we do is we plug in the 9 for the V and the 18 for the R. And I did this here. It's 9 equals I times 18. Divide each side by 18 to get the I by itself, and you're given 1/2 amps of current. And this, students, is a visual representation of what an incomplete circuit looks like. Now this, ladies and gentlemen, is what a complete circuit looks like.
I'm sorry. Hi, I'm Dr. Madeline. So today we'll be learning about parallel circuits. So, unlike the other teacher, we're going to learn something more complicated. So, in a parallel circuit, all components are put together in, what was it again?
Oh, sorry.
Okay. So, all components are connected across each other, forming exactly 2 sets of electrically common points. A branch in a parallel circuit is a path for electric current formed by one of the load components. That's right, I remember now. It's coming back. An example of parallel circuits that I've found is Christmas lights. The reason why is because just because one light goes out doesn't mean the rest of them will. So, a difference between series and parallel circuits is the way you add up the Req, the total resistance. And this is the formula for that. It is 1 over Req, your total resistance, equals 1 over R1, your resistor, 1 over R2, and so on. Okay, so now we're going to find the total resistance by plugging in our resistors into R's. So you have 1 over Req equals 1 over 2 plus 1 over 4 plus 1 over 5 plus 1 over 7. So, which equals this, 153 over 140. Now, in order to find Req, we have to flip the equation, and then we end up getting 140 over 153, which is going to equal 0.917 ohms. So now we have to find our current, and I'm going to do this to separate our problems. So our equation is going to be V equals IR. So I think, we obviously have V right here. So we have this. Our I do not see that we had found yet, so that's what we're trying to find. And our R that we just found. So our voltage is going to be 9 volts. We don't know I, so we're going to put an I in the place. and we know our resistance, so we're going to put 0.917 ohms. And then, once we do that, you have to divide 0.917 by both. And let's do this in the calculator. 917. And you get I to equal 9.8 amps. And this is how a parallel circuit works.
Hello, my name is Dr. Andrew. Today we're going to be talking about capacitors. A capacitor is a device that is used to store electric charge that is consisting of one or more pairs of conductors separated by an insulator. As we go over to this beautifully drawn schematic, the current pushes voltage through this wire towards the capacitor. Voltage is stored into the capacitor, and as current keeps on going back, the voltage that is stored here is used in case the battery accidentally dies. So earlier I talked about capacitors. Right now we're going to try to find the capacitance of a capacitor. Whenever you're doing this, you're going to have your 12-volt battery and your 3.0 microfarad capacitor. This is just known as the capacitance of the capacitor. This is what it can basically hold. Whenever you're doing this, you're going to use the equation Q equals C times delta V. Whenever you plug in your C for your capacitance, which is your 3.0, and then your 12 volts for your V, you're going to get your charge of 36 coulombs. This is how a capacitor works. And then the voltage gets stored into the capacitor until the battery basically dies.